They say that at many companies today, ASIC is a 4-letter word. Now, of course, that's literally true, but also true that doing a semi-custom chip design has gotten so complicated and so expensive that most engineering teams have just about given up on ASICs. It goes like this. Step 1, you have a tough problem that you can't solve with off-the-shelf parts. Step 2, you walk into your manager's office and explain that you need to do a custom chip. Step 3, your manager explains that a new engineer is just about to replace you, so you won't be needing that custom chip after all. Problem solved. But you know what? Here's a secret. It doesn't have to be that way. Triad Semiconductor has a process that makes ASIC design dramatically more affordable. And can I say this on air? Are you sure? Okay. Even kinda fun. There, I said it. They accomplish this using a VIA programmed... Wait, I shouldn't try to explain this. Let's just get started. Hi, I'm Amelia Dalton, host of Chalk Talk. And today I have Triad VP Reid Wender here to tell us all about it. In fact, this is part 1 of a 3-part series where we'll tell you how you can do an ASIC design for a lot less money than you thought possible, how you can do an ASIC design for even way less than that, and then we'll give you an example of this really cool kind of stuff you can design. And remember, before we get started, go ahead and click that More Information link below your player. There you can register for a special VIA Designer discount. Welcome, Reid. Thank you so much for joining me today.
Hello, Amelia. It's great to be here with you today.
Okay, you're making this claim of saving 75%. That's a pretty extravagant claim. Before we jump into that, who are you guys and what's your deal?
Let me give you a little backgrounder on Triad Semiconductor. We were founded in 2002 in Winston-Salem, North Carolina, and we've got a vision for making mixed-signal custom silicon development fast and affordable.
Okay.
We have this patented VCA, or VIA Configurable Array technology, and special VIA-only EDA software. We're a fabless provider of mixed-signal ICs to a variety of industries, including the defense, industrial, medical, and consumer markets. And we've got a highly experienced IC design team going to market with a world-class semiconductor supply chain.
All right, so let's get back to this saving 75% business. But let's back up a second. Why do we even need an ASIC in the first place?
Well, we're always looking for people that have ASIC-sized problems. Typically, you have a board full of parts. You'd like those parts to be in an ASIC or an application-specific integrated circuit. Why? Lower cost, reduced size, weight, and power. Swap's king in a lot of defense markets and medical markets and industrial. I guess swap and cost are king in a lot of places. And it's a way to protect IP, improved reliability, and improved manufacturability. So ASICs are a great solution for semiconductor or IC integration.
Okay, I get it, Reid. Every engineer runs into the need for this kind of integration and optimization, and the next thing every engineer runs into is that an ASIC is a 4-letter word, and my manager says we're not doing them anymore.
I know. You hear the story all the time. ASICs are too expensive. You don't have $1 million laying around for your next one.
Yep.
You're not really wanting to wait 1.5 years to get your IC. And apparently there's people in your company a little averse to risk.
Yeah, imagine that.
They keep asking, when's it going to be done, if ever?
Right.
And then once you come up with this, you've convinced yourself inside your company that you're going to do an ASIC. You go to the foundry and they say, well, we're only interested in talking with you when you've got really high volumes. So if you're not making the next cell phone, you really don't have a whole lot of choice when it comes to getting your next mixed signal IC made.
Exactly.
Well, that's where Triad Semiconductor comes into play. We make VIA ASICs, or VIA configurable ASICs. It's ASIC benefits without the problems. You get the lower cost of ASIC integration, and our development costs are 75% reduction off of a typical IC development. We can do what normally takes 1.5 years in a mixed signal design, a full custom design, in 3 to 5 months.
Wow, okay.
Very low risk because we start with proven silicon, and we'll literally take any production volume.
Wow. Okay. Reid, how in the world are you going to pull that off?
Well, in one slide, I'm going to show you how to be a VCA or VIA configurable array expert.
All right.
It's got our entire Kool-Aid message right here. VIA configurable array technology number one, we're full custom IC developers making mixed signal IP such as op amps, resistors, capacitors, ARM processors, non-volatile memory, band gaps, etc. We make that IP and then we arrange it in tiles. Those tiles are optimized for different functions like single-ended op amps or differential op amp tiles. We have rad-hard versions, peripherals for ARM cores, wideband processing, etc. We then take those tiles and we array them in a VIA configurable array targeted at a particular application space.
I see. Okay.
Here comes the magic. Wait for it. We overlay the array with a global routing fabric. In fact, that's where all of our patents are.
Okay.
It looks like a pretty picture there, but it's really not quite that orderly in the analog domain, and it's very important because we know where to put fabric and where not to put fabric in analog circuits. Then we place and route designs onto that fabric using one of the strangest pieces of software in EDA. It's a mixed signal aware place and route tool.
Okay.
A digital place and route tool is all about optimizing and averaging out, minimizing delay length. Well, we're more about things like equalizing differential routes, putting three-dimensional shielding around signals, doing things that look like twisted pair. We're a tough problem to solve, but after 10 years of development, it continues to get better, and it'll continue to get better over time. Then, all we're sending to the foundry is this single VIA mask layer to be processed against stage wafers. That's the secret in processing time. You're probably used to your ASICs maybe taking 3 months or longer to be fabricated.
At least.
Well, we get it done in under 4 weeks.
Wow. Okay.
Because all we have to do at the fab is process that single mask layer against the staged wafers, and we're able to deliver to you via ASICs in 4 weeks. That's a great feature when it comes time to need to make derivative products or respins, because we can make changes in days and get new parts back in weeks.
Wow. Okay. I think, Reid, I have an ASIC size problem. How would I go about working with Triad?
Well, it normally starts out with you feeding me pancakes in the morning, and then I'll look at your block diagram. No,
all right.
Seriously, we identify that you've got an ASIC size problem, and it's usually a board full of parts that you have a block diagram, schematic, and bill of materials. And for all the reasons we talked about in ASIC, you want to make it smaller,
Sure.
less expensive, lower power.
Yeah.
We'll refine requirements with you and then develop a detailed proposal. Once we kick off a project, in 3 to 6 months, we can have your first VIA ASIC silicon to you.
Very nice.
Respins can occur in as little as 4 weeks. And we're in business to support customers that need to have custom parts for 5, 10, 15 years in the future. So we're in it for the long haul.
All right, Reid, this sounds really good. 75% off of $1 million is still a whole lot of money. I'd give you my company credit card, but I don't think that's going to work. Is there some way to get the cost down to something that doesn't involve a congressional subcommittee?
Amelia, we're a great solution for a customer that knows they're going to do an ASIC. Then 75% off is exactly the right answer. They love the fact that it's faster time to market, lower risk, and lower cost. But for those projects where you'd love to have ASIC integration, but you need even lower cost, we've recognized that, and we're introducing mixed signal EDA tools so that everybody can be their own mixed signal IC designer.
Okay.
We call it VIA Designer. In 2012, we've introduced this high-level design tool where you can do the front-end schematic capture and simulation and RTL entry of your design, but Triad will still do the detailed back-end design, prototyping, production, and delivery of packaged and tested parts. That's a way to reduce your NRE even further, but our goal is to reduce the NRE so that you can save up to 99% off the cost of what mixed signal IC development used to be. We want to make mixed signal IC development as inexpensive as PCB development. To do that, the full flow of VIA Designer, which will be released later in 2013, will allow you to do all of the mixed signal IC design in an easy-to-use set of design tools where if you're a system-level circuit designer, you can now design your own mixed signal chips. VIA Designer, It's based on Mentor Graphics System Vision environment, which combines Model Sim digital simulation, Eldo analog simulation, VHDL Verilog, VHDL AMS, and SPICE, and easy-to-use design wizards.
Great. It's been wonderful speaking with you today, Reid, and I'm excited to come back for another Chalk Talk and talk about a further savings plan.
Amelia, thanks for the time today. As well, I can't wait till we talk about VIA Designer, and we're going to turn you into a VIA Designer for sure before this is all over.
Sounds great. And before we go, don't forget to click that More Information link below your player. There you can register for a special VIA Designer discount. For Chalk Talk, I'm Amelia Dalton. For more Chalk Talks, check out the on-demand section of eejournal.com.